Imagine it's summertime and you decide to visit a warm lake. You dive under and a little water goes up your nose. Happens to everyone. It stings for a second. You surface, shake it off, keep swimming. 5 days later, you have a headache. 3 days after that, you're dead. Now, you must be wondering what could possibly cause this. And the answer is Naegleria fowleri, a microscopic organism that lives in warm freshwater. Lakes, rivers, hot springs, poorly maintained swimming pools. Anywhere the water is warm and inviting and you want to cool off on a hot day. The weird thing is that it doesn't even want to infect you. You're not its preferred food. It only eats bacteria, actually. But when you accidentally snort it up your nose, it gets a tad bit confused and decides to take a trip up through your nasal cavity, along your olfactory nerves, the ones that let you smell things, through a tiny bone plate in your skull called the cribriform plate, and straight into your brain. And once it's there, it starts eating, but not bacteria anymore, rather your brain cells. The astrocytes and the neurons that, let you think and move and be a person. One of the more infamous and rather sad cases is when this happened at Disney World in 1980. An 11-year-old boy went swimming at River County, Disney's water park. The happiest place on earth, where kids splash around and parents relax and everyone's on vacation. He got a headache a few days later, then a fever. Stiff neck. His parents thought it was the flu. It wasn't the flu. By the time doctors figured out what was happening, he was having seizures, hallucinating, slipping in and out of consciousness. It was already too late. He died less than 2 weeks after that swim. The symptoms look like meningitis at first, so doctors treat it like meningitis, which doesn't work because it's not meningitis. It's an amoeba eating your brain in real time. Even when they figure it out, the survival rate is about 3%, and that's generous. From 2013 to 2022, 29 people in the US got infected. 4,000 people drowned in that same period. You're statistically more likely to die in the water than from what's in it. But statistics don't mean much when you're the one who happened to inhale at the wrong moment in the wrong lake on the wrong day. There's a treatment for it, of course. It would be weird not to have one in 2025. Amphotericin B, an antifungal drug. Sounds promising until you learn that promising still means a 97% chance you'll die anyway. The amoeba doesn't spread between people. You can't catch it from someone who's infected, just from going swimming, from doing something humans have done for thousands of years to escape the heat. So, the existential kicker here isn't the amoeba. It's that we know about it and we still go swimming anyway. Because what's the alternative, right? Live in fear of a 0.001% chance? Stop cooling off in lakes because some microscopic organism might accidentally wander into your skull? That's like refusing to go out because a car might hit you. That's the psychological trap of modern information. We know too much about rare horrors. Our ancestors just died randomly and called it God's will. We die randomly and call it a statistical anomaly, which somehow feels worse. But yeah, no, now I kind of feel like something's wiggling inside my skull. And this feeling is only gonna get worse as I go on with our next case. Ever get an eyelash stuck in your eye and spend like 20 minutes trying to fish it out? Yeah, now imagine you finally grab it, pull, and it wiggles. Abby Beckley, 28, Oregon, 2016. She felt an irritation in her eye for days. You know, that annoying scratchy feeling like something's in there but you can't find it. She's looking in the mirror, pulls at what she thinks is the problem, and out comes a translucent worm, half an inch long, moving. I looked at it and it was moving, she said, and it died within 5 seconds. Cool. Totally normal Tuesday. Except it wasn't just one. Over the next 3 weeks, doctors pulled 14 worms from her eye. 14! Not a typo! The species, Thalasia gulosa, cattle eyeworm, the kind that's supposed to live in cows, not humans. It's spread by flies and feed on tears, because apparently flies have a thing for eyeball moisture. When flies hop between cows, they drop larvae into the eyes. The worms hatch, feed on tear proteins, grow, mate. Then the cycle continues. Abby had been horseback riding near cattle pastures where flies were swarming. One of those flies decided to diversify its clientele and gave her a little gift, a living one that reproduced in her eye. For weeks, she could feel them crawling across her eyeball. Not maybe something's there, actually watching worms move across her field of vision, the thing you use to see the world, now hosting tiny tenants that feed on the fluid keeping your eye functional. This was the first documented human case of this specific cattle worm, the 11th eyeworm infection in North America overall, which means 10 other people have also experienced the horror of their eye becoming a parasitic nursery. Parasites evolve to exploit specific hosts, but when conditions align, a fly with the wrong meal plan, proximity to livestock, a few larvae in the right place, biology just shrugs and adapts. Abby didn't do anything wrong. She just went horseback riding and left with 14 passengers she never agreed to host. Jeez, did my eyeball just wiggle? Ever blame a mosquito for ruining your picnic? Annoying little pricks, aren't they? But it turns out, sometimes they act as the delivery system for pricks even more so annoying and even more so little. A single-celled parasite, hitching a ride in its spit. Malaria isn't caused by mosquitoes. It's caused by Plasmodium, a microscopic organism that eats your body like an all-you-can-eat buffet with free lodging. The mosquito just drops it off. Here's how it works. Female mosquito bites you, injects saliva to keep your blood flowing, and whoops, that saliva contains Plasmodium sporozoites. Sporozoites sounds fancy, but it's just what the parasite is called when it's in travel mode. They enter your bloodstream, head straight to your liver, and set up camp. For about 2 weeks, they multiply silently. No symptoms, no warning, just thousands of parasites growing inside your liver cells, waiting. Then they break out. The liver cells rupture, releasing merozoites, which is just what the parasite is called when it's in attack mode, into your bloodstream, and they go straight for your red blood cells. They invade them, eat them from the inside, multiply, then burst out to infect more cells. Your red blood cells essentially become parasite factories that explode every 48 to 72 hours, releasing waves of new parasites into your blood. That's why malaria has that classic fever pattern. Every 2 or 3 days, millions of red blood cells burst simultaneously. Your body detects this, freaks out, and gives you intense chills, then fever, then sweating. It's not the infection causing the fever, it's your blood cells detonating on schedule. But it gets worse. Plasmodium falciparum, the deadliest species, makes infested red blood cells sticky. They clump together and stick to blood vessel walls. This blocks blood flow to your organs. Brain, blocked vessels cause seizures, coma, death within 48 hours. That's cerebral malaria. Lungs, respiratory failure, placenta during pregnancy, low birth weight, miscarriage, stillbirth. The parasite doesn't just eat your blood cells, it turns them into biological roadblocks. In 2023, malaria infected 263 million people, killed 597,000. That's about 1 death every minute. 95% of those deaths, sub-Saharan Africa. 67%. Children under 5, kids who've barely started existing, stopped by a parasite smaller than a speck of dust. There are vaccines now, RTSS and R21. They reduce cases by 40 to 75% in children, which sounds great until you realize that means millions still get infected despite vaccinations. Bed nets help, insecticides help. But the parasite adapts. Mosquitoes develop resistance, Plasmodium develops resistance, and the cycle continues. Here's the thing about malaria. It's not just a disease, it's a feedback loop of poverty. It thrives where healthcare is inaccessible, where bed nets are unaffordable, where standing water can't be drained because infrastructure doesn't exist. It kills the people who can least afford to die, takes parents from children, children from parents, and leaves communities too sick to work, too poor to treat, too exhausted to break the cycle. Malaria doesn't just kill individuals, it strangles entire economies, entire futures, one exploding red blood cell at a time. A mosquito bite lasts a second. The parasite it delivers can kill you in weeks. Ever feel a pimple forming and obsessively check the mirror to see if it's getting worse? Now imagine checking the mirror and the lump has moved to a different part of your face. Russia, 2018. A woman notices swelling on her cheek. Annoying, but whatever. Probably an insect bite or an allergic reaction. She ignores it. A week later, it's on her lip? Another week, her eyelid. Yeah, the lump was taking a tour of her face. She finally went to a doctor who did some scans and found a worm living under her skin, just casually wandering around it like it was sightseeing. The species? Fowleri ripens, a roundworm that normally infects dogs and gets spread by mosquitoes. It's always those pesky little mosquitoes. When a mosquito bites an infected dog, it picks up larvae. When that mosquito bites you, it drops the larvae under your skin. In dogs, the worm matures, reproduces, completes its life cycle. In humans, it just wanders aimlessly because it can't finish developing. Your body isn't the right host, but the worm doesn't know that, so it just migrates under your skin, confused, looking for something it'll never find. The doctors surgically removed it. The videos went viral because watching a worm move under someone's face in real time is the kind of thing that makes your skin crawl, literally. Ever have a headache that just won't go away? India, 2007. A man walks into a clinic complaining about headaches, also nosebleeds, also a smell coming from his nose. You know, that smell you get when something's rotting, except the rotting thing was inside his face. Doctors look inside his nostrils and find his nasal cavity packed with maggots. Not a few. Dozens, squirming in there, eating. His sinuses had become a nursery for fly larvae that were actively consuming the tissue inside his head. Here's how you end up with maggots living in your face. A fly lands near your nostrils, lays eggs, tiny eggs, almost invisible. Within 24 hours, they hatch. The larvae crawl inside because that's what they do. They follow warmth and moisture. Once inside, they start feeding. Dead tissue first, that's the preferred meal. But when that runs out, they're not picky. Living tissue works fine. The man could feel them moving. That sensation of something foreign squirming inside your nose, except it's not foreign anymore. It's residents. They're setting up shop. The headaches were from the maggots burrowing deeper into his sinuses. The nosebleeds were from them chewing through blood vessels. The smell? That was tissue decay, his own face being digested from the inside while he was still using it. If left untreated, the larvae don't stop at your sinuses. They keep burrowing through bone into your brain. At that point, you're not dealing with a parasite problem, you're dealing with a countdown. Doctors removed them one by one, manual extraction, endoscopic tools, flushing the cavity with saline to wash out the ones they couldn't reach. Imagine the sound, the wet squelching as each larva gets pulled out. Ew. The smell described as overwhelming, which is medical speak for everyone in the room wanted to resign. The man survived, took ivermectin to kill any stragglers, went home, probably slept with his windows closed for the rest of his life.